Hey guys, how's everything going? Today let's take a look at number 60 of LeetCode permutation sequence. We are getting the set 1 to n. We need to find the kth permutation sequence, like 1 2 3, 1 3 2, 2 3 2 1 3 3 2 1, and this is the restrictions. Say we're going to have the permutation sequence of totally 3 numbers, and we are going to get the third sequence, which is 1 2 3 1 3 2, and third one is 3 2 1 3. So we return 2 1 3. Well, the first naive solution comes to my mind is that we can just find the permutation one by one, right? Yeah, we actually did a similar question, which is this one. This is 46. If you haven't seen it, please search on my channel about number 46 permutations. Here we're using backtracking with just the recursion and find the result. So I'll just first I copy the solution here, okay? Yeah, this solution actually collects all the possible sequence in the final result. But in our number 60, we don't need to return all the solutions. We just need to, for the ranking, need for the specific result. So rather than collecting the result, we need to get a count, I think, right? Let's say the final result will be, let it to be undefined, and let's count equals to, we will stop the traversal when we met this target k, right? So the count should start with 0, and every time we found a solution, we increment the count, okay? So the original solution is very simple. We pass 2 parameters to the recursion function. The first one is the temporary result, and the other one is the rest available digits, right? The first we passed at the beginning, we don't have any digits in our intermediate result, so all the numbers are in the second parameter, and every time we pick a number from the second parameter and push it into the first one, and then we do the recursion one by one. Yeah, that's pretty straightforward, right? Okay, so when there is nothing in the second parameters, that means all the digits are traversed. This means a new valid permutation sequence comes around. So if this is true, the original one we just push the result, collect the result, but here we will count it up, right? Count the count and add the check. If count equals k, we will update the result equals temp, right? We join it, convert it into a string. Yeah, and if it is not the end, we pick the one from the second parameter and just continue doing it. Yeah, it's cool. And actually, yeah, our solution is done. I'll just say this is the backtracking naive. Yeah, it's very naive. But there's a problem that because for the original solution, we will continuing all possible solutions in a one walk, in a one recurring function, which means for the first 3 numbers, like 1 2 3, for this for loop we will traverse for 1, for 2, for 3, right? Even if we turn here, but we will still continue. So all these possibilities will be checked, and the result, or of course, it's right, but the time is not good. Time complexity is really not good. So we need to stop this recursion right away. That means we cannot just return here. We need to add a second state for this recursion function, which means if it is fails, I can continue. If it is already matched this result, I will just stop right away, right? Okay, so if it is the case, it means we find the result, we return 1, and if not, we return 0. Oh, yes. We return, okay, return 1, and if with default return 0 means we haven't met the end of the permutation each sequence yet. So here, for the rest, we walk, but we need to, for the loop here, we say result walk. If in this we found that it is checked, it is done, then I say we just return 1. Yeah, so that we can just cut the unnecessary recursion and walk return result. I think we are doing good. Let's try. Oops, there's some nums is not defined. Oh god. Nums. Yeah, we need to generate nums. Okay, we say nums is empty, and the n, right? N is not used at all. So while n 1 nums unshift nums okay, n minus equals 1. This will n when n becomes 0, so this nums is right. Okay, let's run it again. Hope it works. Oh yay! Let's submit. Yay! We are accepted, but it's super slow. Like we are only faster than 5% of the JavaScript. 5% It's very slow. It's actually, we can count it out because we need to generate, actually traverse all the possible permutation sequence, right? The first one, the second one. Actually, we need to literally we need to generate all the sequence one by one. And wait here, it's actually not. Oh, okay. After we improve the solution, the time complexity will be okay, I think. Okay. This is what is the time? Wait a second. If I did like this, every time we pick a number to it, and then for loop, and then walk again. So every walk actually checks every possibility, so it's actually okay. I'm not sure. And space, actually the maximum depth of the call stack is actually the length of the digits, right? So it's maximum n, right? And here we need to, yeah, here is O n. You see that k will be between 1 and n factorial of Fibonacci? No, factorial. Factorial? Of n, it's super big. Let's try to improve it. Let's try. How can we improve it? Let's just take a look more into this example. For 1, 2, 3, we need to get the third, like we need to get the sixth of the permutation. Actually, you see that if the first digit is 1, we know that all the combinations, all the permutations of the rest 2 digits will be, the count of it will be 2, right? Only 2 possibilities for 2 numbers. And so for the digits 1 and 2 as the first numbers, there will be four possibilities. And we are asked to get the sixth possibility. That means the first digits must be 3, right? So we can just deduct the first digits by purely math. And then we can do this recursively, and the problem becomes like we, after we decided it's 3, then the possibilities for when it's not 3 will be 4. So we are going to find the second permutation of 2 digits, which is 1 and 2, right? So, and 1, 2, it will be 2, 1. And if we're going to generate the fourth sequence, we can deduct by a pure math to decide the first digit to be 2, and we're going to get the second permutation of the numbers 1 and 3, which is not 1, 2 anymore. So these also two possibilities. So it's 2, 3, 1. So actually, we can improve by avoiding unnecessary, I'm not sure I have the right spelling, generating jump steps. So for that case, we means decide each digit from left to right. In that case, we need to know before time that how many permutations would be for a specific n, right? So it will be, we need to first generate the factorial array of n, right? First, get the factorial array. Is it factorial? Let's say factorial. Oh yeah. Kaijo, yeah. It's factorial. Cool. So the first factorial of 0 would be 1, right? But actually it's not used. For 1, it's 1. For 2, it's 2. Okay. So we start with 3. Let I equals 3. We push the previous one. Would be times, right? Yeah. Times. Yes, times n. So this means means there will be fact n possibilities for n digits. This is very important. So now, what is the first digit of k possibilities? Kth possibility. Well, it's simple. We just traverse through the factorial and find the target, right? Yeah, the k might be big and small, so well, naively we just traverse through the factorial. Okay, so how we can find the first one? So if this one, there will be, for each digit, there will be fact n minus 1 possibility. Yeah. So the possibility would be, so the index of the numbers, right, would be the k divided by fact n minus 1, right? So for the first digit, and math floor, right? Is this right? Yeah, let's say for the k equals 1, then the first index should be factorial n minus 1. It's 2 4, so 4, yeah, it's 0, so it should be the first number, which is 1, index, right? And the second one, when we are getting to number 2, the previous, if there are only 2 digits, right, so we are checking 1 and 2, the n minus 1 will be 1, so the factorial will be 1, and the k will be 1 or 2. If it is 1, then it will be 1. So 1 1 1 will be always, index will be 1, but it should be 0, right? So actually this is not right. Considering k equals 1 and n equals 2, it should be CO minus 1. This is a trick, and it's actually right, I think. It should be the first, it should be the next possible, it should be the permutation between the next possible permutation, right? So for k and for k equals 1 and n equals 2, it should be always be 0. But mass floor doesn't match that, so it should be mass ceiling but minus 1. For now, if k equals 6 and the factorial n 2, it will be 4. So this should be 1, right? 1 minus 1, yeah, 0. So the problem is should be smaller than 0 1, it should be 0. Yeah, that means 1 between 2, it should be 1. So it's CO minus 1. Yeah. Okay, this is how we get the first digit, right? So how can we get the second digit? It's the same, unless k should be subtracted with the possibilities of this index number. Okay, considering this, we will first get all the digits nums. It's the same. We will just generate the digits by a while loop. Let's make it to center. Nums on shift and okay. Now let's move to the here. This is here. Okay. Now we will do the same thing. We will try to get the first digit and get the second digit. So there will be a result, right? So every time we will get the digit and push it to the result. So there will be result nth. Well, okay, we'll say while nums has numbers. While there is a number, we will get the first digit. So this is the index, right? So this is the index. And we will push the result, right? Push nums index. Now we need to splice the result index of result, right? Remove it, right? So splice index 1. And we need to reduce the k. So after we push these numbers in it, then how many possibilities are left to the rest, right? And there here is mistakes that this should be based on the not n. This should be based on the nums length. Yeah. So here it should be nums length. An index, remove the number, get the first digit. Okay, update k by removing the possibilities. Like just for this example, we now decided the first letters should be 2, right? Now the possibilities would be so 1 2 3 1 3 2. It would be, yeah, you know, that should be the possibilities when the first letters first become this number, and that would be the counts of all the possibilities with a number smaller than this one. Right? So the index would be, if it is 0, then there's no possibility. Index is 1, so there are 2 numbers. The second numbers, right? The first numbers, the possibility are all taken. So k should be subtracted with index times the possibilities of the previous one, right? Just this one, factorial nums length. But actually we splice it, so the k should be updated first. Yeah, we get the index, and then we update the k, and then push numbers. Oh yeah, and then we return results, join. Let's run the code. If we do this first, these will cost us on, but this it will be still on, right? Wow, it's something wrong. memory is I think there is something. Oh, nums. It's really because of infinite loop. So yeah, it's on. So it's still on. Time on space. Nothing special. We hold the rest. So it's on. There's still something wrong. Why is K? My God. For loop here is okay. For here, while loop is here okay. This loop is okay. Yeah, we're accepted. Let's try submit. So the solution actually, the first we can come up with a pretty. Ooh, we got the wrong answer. Let's debug why 4912123134. We got 2314. It's 4. Result push. I don't know what the problem is. Let's console log index. Nums index. Okay. This is result, so the rest is nums n minus 1. This is right. Maybe this is wrong. Okay, we got index. The first one is k, so we get numbers of 2, right? Yeah, and the final numbers will be okay. 2 k is k now becomes 1. Oh, this one, yeah, this one. So this will be 6 possibilities. So we will k will be if it is 2, then k will be 3 possibilities. So k should be 3. Now it becomes 1. Wait, nums is 2. K should be 3. First k was 9, right? Factorial 3 will be 8. God, it should be I. Okay. Yeah. We had a problem with the factorial array. Wow, that's a huge mistake. Submit. Oh yay, we're accepted this time and we are run faster than 93%. Wow, it's improved a lot. We improved the time from OK to ON. K will be just wow, it's a huge improvement, you know. K is between the factorial of n, so that's a huge improvement. So that's all for this problem. Hope it helps. So the lesson I learned from this problem is that first, for any problems, we can just come up with a naive solution with recursion or backtracking. Backtracking is based on recursion, so everything could be basically done with recursion, and then we try to understand the problem, find the way to cut down the unnecessary calculations, like this one. Yeah, we can just say some of the calculations are not. We don't need to get all the final result. We just need to get the count. If that's true, we can just count by the pure calculations, and then decide the digits one by one. So recursion and pruning, recursion and pruning, recursion and pruning. Yeah, recursion and pruning. Okay, that's all for this. See you next time. Bye bye.